From the Library of Congress in Washington, D.C.
Okay, welcome, good day. Delighted that you're spending part of your day with us at this incredible event, the National Book Festival. I'm honored to be here. My name is Steve Inskeep. I work for a little radio network called NPR. And, okay. Thank you. I will accept that applause on behalf of my colleagues at NPR, who are great. And I am delighted and honored to be here putting a few questions and helping, I hope, to lead a good discussion with David Quammen. He has done here one of my favorite kinds of books, where you take a huge subject and you grab one slice of it and put it between two covers so that someone like me can read it very quickly, almost in one sitting, and it makes your head explode because it's so interesting. Some of my favorite books have done this. Shelby Foote, the great Civil War historian, has a 3,000-page history of the Civil War, 3 volumes. From that, many years ago, he pulled out 2 slim volumes about the battles of Gettysburg and Vicksburg, which were just as short as I'm describing here, incredibly poetic, that were incredibly memorable and stuck with me a long time. And then I got a chance to pick up this book where David Quammen has done the very same thing. The Chimp and the River is a single chapter from a much larger book, a single dramatic story, and even though he tells you how it's going to end on the first few pages, it's almost a suspense story because you wonder how on earth could you get to that ending. David, why don't you describe what the story is? What is it you're pursuing in this little book, The Chimp and the River?
Well, first of all, I'll say I'm delighted to be here too, and glad that you all have shown an interest in this, and delighted to be talking with Steve. I'm one of many of us who hears his voice every morning, so it's nice to hear it from 4 feet away. Yeah. The book is about the where, when, and why of the AIDS pandemic. Where, when, and why or how it began. It's a book on the ecological and evolutionary origins of the AIDS pandemic, and that means where did the virus come from? It came from an animal because we know it's a zoonotic virus. It had to come from somewhere. It wasn't in humans before. So some scientists working in the field of AIDS research set out to solve that mystery. Where had it come from? What animal? When? What part of the world? And how had it gotten into humans?
Now, you just said a word that I never knew until I read it in fact, I'm glad you pronounced it for me, zoonotic.
Zoonotic.
And that is pointing toward a really big idea that you're exploring here, which is...
Right. A zoonotic disease is a disease that comes from a non-human animal. A zoonosis is an animal infection that's transmissible to humans. Steve mentioned my larger book from which this is drawn. It's called Spillover, and it's about that whole subject, about the subject of zoonotic diseases, human diseases that have originated in non-human animals and been spilled over into humans.
And so you wanted to know about perhaps the most famous in modern times, or one of the most deadly in modern times, examples of this. Why?
Right, because some of these diseases are very dramatic but very small in impact. There's a disease that is caused by a virus called Hendra virus in Australia. We now know it spills out of bats, gets into racehorses, goes from racehorses into veterinarians, racehorse trainers, usually kills them. Very small, but very dramatic. It's killed less than 10 people total. You used to be able to say that Ebola was a relatively small disease, Ebola virus disease. And then we had the horrible events of last year, which are still going on right now in West Africa, although it's tailing off. So I was going to be writing about these various peculiar, dramatic, zoonotic diseases, Ebola, Hendra, SARS, and a number of others, Nipah virus out of Malaysia and Bangladesh. But the 800-pound gorilla in the room was AIDS. Originally, I was asked to write about zoonoses for National Geographic, probably back in 2007. And we made a strategic or tactical decision that in a relatively short magazine piece for National Geographic, 5,000 words, I would not open the subject of AIDS because it was just too big, too important, too gruesome and wide in scope to be put in a 5,000-word article with the number of other diseases. It would have overwhelmed everything. So I completely omitted AIDS. I didn't deny that it was zoonotic, but I just omitted it from the magazine version. Then when it came time to write the book, I said, now I'm able to come to grips with the AIDS pandemic as a zoonotic phenomenon. And I started writing this chapter. It falls near the end of my book. And as I was writing it and going deeper and deeper into the material, I realized I'm really writing another book. This is a book within the book. So even as I was writing Spillover, I had the sense that it should be also perhaps a short standalone book.
Now, plenty of people have tried to trace the virus that causes AIDS, or the viruses that cause AIDS, back to their origins. I, as a layman, had heard something about this, and if you'd asked me before reading this, how far back have they traced AIDS, there are some dates rattling around in my head. I might have said, about 1980 was when the first case was, and then I might have thought a little more and said, I think there was something in 1977. I might have heard of someone called Patient Zero. Yeah. But you have another date in this book, and that was actually the head-exploding date for me. Tell me how far back you traced this.
We now know from very good molecular work that's been done by several different teams that the AIDS pandemic began with a spillover from a single chimpanzee into a single human in the southeastern corner of Cameroon back around 1908, give or take a margin of error. 1908. And that was what was new in the science that was published 2006, 2007, 2009. So it's very recent stuff, it's very persuasive, and it's very counter to what we have all thought we knew about the origins and early years of the AIDS pandemic.
Give me a short version of the answer to the question that I'm sure many people are now asking themselves. How on earth could we possibly know that the disease went back to a particular place in 1908?
Well, the short answer is two words: molecular phylogenetics.
Okay, our work here is done.
Molecular phylogenetics is using genome sequencing to draw family trees. That's what molecular phylogenetics is. And we know the when of the beginning of the AIDS pandemic because a fellow named Michael Warraby and his colleagues has done molecular phylogenetics on two particular genomes, two particular HIV-positive humans who left behind, in one case, a blood sample, in one case, a tissue sample, in 1959 and 1960. In Kinshasa, as it's now known, formerly Leopoldville, the capital of the Belgian Congo, these two people, one was a man and one was a woman, their history is unknown, but they left behind samples, a blood sample frozen and a tissue sample preserved in paraffin. So we know those two people, the tissue samples were screened, blood samples were screened. Those two turned up HIV positive from retrospective screening, 1959 and 1960. Michael Warraby sequenced portions of the genome and then placed that in a computer program that would map it on a family tree with all of the known, a large number of known sequences of DNA from modern patients, and he found that those two sequences were different enough from each other that they had to have diverged by about 50 years, according to the assumptions of molecular clock.
Oh, because viruses evolve the same way that other creatures evolve.
Viruses evolve, viruses mutate when they replicate themselves. They make mistakes copying their genome, and you can add up the number of times that they have mutated, the number of differences between one virus genome and another, and you can infer backwards how long it's been since they had a common ancestor. And you do that by knowing roughly the time frame at which they mutate, their rate of mutation. So you can turn that into time to most recent common ancestor. Michael Warraby did that, time to most recent common ancestor of these two samples from 59 and 60. What he got was roughly 50 years. The mathematics are a little bit more complicated than that, but that's why he put it to 1908, give or take a margin of error.
So, as best you can determine from the available evidence, what exactly happened in Cameroon in 1908? There was some kind of encounter?
Well, something happened probably earlier than that, or it may have been earlier than that, a little bit earlier. What happened was an encounter between a chimpanzee and a human. And this involves work done by Beatrice Hahn, another scientist. She was the one who discovered that the precursor virus of HIV, the pandemic strain of HIV, and that's known as HIV-1 group M, that's the pandemic strain. There are a number of different groups of HIV, and there are two major kinds, HIV-1 and HIV-2. I don't want to get too much into the weeds, but the pandemic strain she found, again with looking at the genome, the genome sequencing, she found that all of the diversity of human AIDS around the world was sort of a little branch on a tree, a family tree, and that little branch placed itself in a very particular spot on the large family tree of HIV sequences, matching extremely closely the precursor virus found in chimpanzees in the southeastern corner of Cameroon. I didn't explain that very concisely, but I hope you know what I mean.
You're saying that the chimpanzees were carrying around a virus that was similar to but not the same as what became HIV, and it wasn't any big deal to the chimpanzees.
We thought it wasn't any big deal. We thought for years that it did not cause disease in chimpanzees. And so it was thought that this became, in chimpanzees, we now call it SIV, simian immunodeficiency virus, but we thought that it doesn't cause immunodeficiency in chimps. This is something else I describe in the book. And then it was discovered through collaboration with Jane Goodall and the chimps that she had studied for years at a place called Gombe in Tanzania, that those chimps, many of them were positive for this virus, carrying it. And again, Beatrice Hahn's group worked with Jane Goodall, and they found that indeed this virus was killing chimpanzees at Gombe, killing Jane Goodall's chimpanzees. Those chimpanzees that were SIV positive had a 10 to 16 times greater likelihood of death than others. Sometimes they disappeared, and sometimes they died and were found, autopsies were done, and they were found to have immunodeficiency symptoms.
So there was this random moment somewhere around 1908, give or take, and you said an encounter between a human and a chimpanzee. So someone, killed and ate a chimp or was bitten by a chimp, something like that happened?
Blood-to-blood contact must have occurred. And this is what is called the cut-hunter hypothesis. Beatrice Hahn and other scientists talk about this. It's the exact way in which the spillover occurred is unknown and probably unknowable. So there is this hypothesis, the cut-hunter hypothesis, that around 1908, in the southeastern corner of Cameroon, a single human killed and butchered a chimpanzee and had blood-to-blood contact. Presumably it was a man. They did most of the hunting. It might have been a woman butchering a carcass that a man had killed. That person perhaps already had a cut on his hand or cut himself while he was butchering the chimpanzee, got chimpanzee blood into his cut, and became the real patient zero, the first HIV-positive human.
There are several, to me anyway, profound questions that are brought up by this example. One is just a realization that while the science is incredible, they had to have evidence. They had to have blood samples or tissue samples to test. And to state the obvious, no one was saving tissue samples in 1959 for the purpose of figuring out that HIV was in them later. Right. You describe in the book personally going to Kinshasa in this war-torn capital and finding a particular lab where some of the stuff was being held, had been held almost undiscovered for years. What was the circumstance that led to anything being preserved long enough that people could find this out?
The circumstance was routine biopsy procedures and the saving of biopsied material tissue from humans who got sick from one thing or another, died of one thing or another. If a biopsy was taken or an autopsy was performed, tissue was routinely saved in little blocks of paraffin. There was a process where you could take a little tissue sample and you would dribble this wax on it, almost like dribbling out a little pat of butter, and then it would solidify, and the tissue would be in there with preservatives. So this was done in the late 50s, in the early 60s, routinely it was then Leopoldville, capital of the Belgian Congo, and then it was Kinshasa. And they were stored in this little cupboard at the pathology lab of the University of Kinshasa, as it's now known. And this is where Michael Warby got one of his specimens for this work that I described. And I had read about that, and then I decided to go and see this lab, and I found this man, Jean-Marie Kabongo, a very, very sweet, helpful Congolese pathologist. And he took me into this lab. I told him why I was there, and he said, well, I can't tell you about that famous specimen. It was called DRC-60, Democratic Republic of the Congo, 1960. I was looking for the origin of it. He said, well, I can't tell you who that was or what that person died of. But it was stored here. And I said, really, stored where? Well, he said, come with me. And he took a key and he opened a blue door, and we went into this lab, a pathology lab, with a General Electric refrigerator and some old equipment and a ledger book and some beakers on the ledge. And then he said, come here. And he pushed aside a curtain, again, a blue curtain, and there was a little pantry. And in this little pantry were these stacks and stacks and stacks of paraffin pats, each of which was preserved biopsy material. And he said, it came from here. And I said, wow. And it sat there. It sat there from 1960 until about 2005. And then a man named Jeje Muyembe, an eminent Congolese doctor, said, you know, those specimens might be helpful in the search for the origin of AIDS. He put 800 of them in a suitcase, or an ordinary suitcase. He got on a plane for Belgium, and he went...
I'm just picturing the moment in airport security with that. Go on.
And he carried these tissue, and he handed them to another scientist named Dirk Tuin in Belgium, and he said, here. And Dirk Tuin then said, well, I'm going to send some of these to Michael Warby. We have an agreement with him. He's in Tucson now. So he sent some to Warby, and Warby then started trying to extract some sequences of DNA or viral RNA from these tissue samples. He worked on 27 of them out of the 800 because it's a very difficult procedure. And from those 27, he assembled some good genome sequences of one, and that became DR60. And the other specimen, or DRC60, the other was ZR59. So he compared DRC60, ZR59, and he found 50 years of divergence since the virus had gotten into human beings.
I'm just thinking about if you travel to a very old city or a city that had an ancient past, you can marvel at how one building survived or one temple survived and another was not at some point. You know, quarried for stone, knocked down by ISIS, whatever might happen in an ancient city. This almost to me seems the equivalent. I'm just marveling at the idea that for 45 years, in a country that suffered coups, that suffered violence, that suffered poverty, that suffered civil war, you could imagine so many ways that those samples would have been thrown out, that the building would have been torn down, that the lab would have been abandoned or turned to some other use, that it would have been hit by an artillery shell. I mean, any number of things could have happened that would have destroyed that tiny trace of evidence that allowed this detective story to be solved.
And I would attribute that to two things. To luck that the building wasn't bombed, and luck that the pantry wasn't cleaned out, and to the quiet professional dedication of people like this man, Jean-Marie Kabongo, and the people who had preceded him, who had this sense of professionalism, working with miserable little salaries and old-fashioned equipment, but saying, I am a doctor, I am a pathologist, I have a mission, I will do my science and do my human medicine quietly here, no matter what happens, with very little reward, because I'm dedicated because I'm a professional. This was a wonderful man.
So you trace this backward in time to roughly 1908, when this transmission, this spillover took place. You also try to trace it forward, because then the question is, how did this disease get from a remote corner of Cameroon around 1908 to eventually the United States?
Right.
How'd that happen?
How did it get there, and why did it take so long?
Yeah.
And I describe that in the book. At a certain point, there is a gap in what is knowable from evidence. So I try to fill that gap, and I do something that's maybe the riskiest thing I've ever done as a nonfiction writer. I create a hypothetical scenario, but I let the reader know very specifically, I'm imagining this. This is a hypothesis. I begin with the cut-hunter hypothesis, and I tell a story, a narrative that is hypothetical about a man who becomes infected in the southeastern corner of Cameroon in about 1908 and carries the virus downstream, down the little Ngoko River to the Sangha River, down the Sangha River to the main stem Congo River, down the Congo River to the big capital cities of Brazzaville and, as it was then, Leopoldville.
The rivers just happened to flow that way, and so that's how
where the
human
rivers
traffic
went.
Yeah.
Yeah, and the rivers were the highways in those days. And so I create a hypothetical, but I hope very plausible and detailed story of how that might have happened. That's my narrative hypothesis. And it's the story of, I call this fellow the Voyager. He has a couple of elephant tusks that he decides that he needs to escape from where he is, and he wants to go to the big city, and his canoe carries him down the rivers, and he carries the virus with him.
Is more known factually of what happened after that, or is it still something of a mystery?
It's still something of a mystery as to what happened up until 1959 or 1960 when we have those positive samples. But there are some important inferential facts that can be filled in. One is that the virus was moving from one person to another very slowly at the beginning. For each person who had an infection, roughly only one person was becoming infected. It wasn't multiplying. It was just barely sustaining itself in the human population. Otherwise, we would have known about it. But then when it got to the cities of Brazzaville and Leopoldville, it met different circumstances. Sexual mores were different. People had more sexual partners. There was a greater population density. And another factor that may have been important was that hypodermic syringes were being used to treat other diseases, to treat sleeping sickness, trypanosomiasis, to treat malaria, to treat syphilis. People were running around with medical people were running around with hypodermic syringes, injecting people, injecting thousands of people sometimes with the same syringe that only got rinsed, perhaps in distilled water, maybe at best in alcohol, between injections. And so an AIDS historian named Jacques Pepin has developed that story, and I benefited from his work and tell that story about these clinics and these medical initiatives that involved injecting more and more people. And probably moving AIDS from one person, moving HIV from one person to another in the course of doing that.
Some people would be getting sick, would be dying, and it simply was never being properly diagnosed.
It wasn't being diagnosed, partly because life in Central Africa in the early part of the 20th century was very difficult. Life expectancy was short, so a lot of people may have been HIV positive and died by getting gored by an elephant during an elephant hunt, might have died in a fight, might have died of a lot of different things, might have died of malaria before they had any immunocompromised symptoms. Or some people may have been dying of immune deficiency. There were a lot of diseases being passed around. They might have been more susceptible to that, but it wasn't recognized because life was hard and life was short in Central Africa.
So this disease existed in humans and went undetected for, give or take, 75, 76 years.
Right. And then in 1981, it turned up on the radar screens in Los Angeles and New York.
And took several more years even for people to figure out exactly what was going on.
That's right, yeah.
What does that make you, like when you learn that story and then you leave the National Book Festival and head out onto the streets and are looking around, what does that make you think about what might be going on now?
Well, it makes me think that we haven't seen the last of new diseases that come from non-human animals. Because people in the tropics, particularly poor people living in villages close to the forest or within the forest, in the tropics, in Africa, in Asia, and elsewhere, are hungry for protein, they're hungry for food, they're starving, and they eat wildlife. We eat wildlife in America too. I mean, I come from Montana, and we eat plenty of wildlife. We call it game. But when people in Africa eat wildlife, it tends to get called bushmeat, and it has a slightly negative connotation, unfairly. However, one thing that is objectively different is that there are non-human primates in Africa that are being eaten as bushmeat. And those non-human primates carry a lot of viruses, and those viruses in non-human primates are more likely to be able to take hold in humans than viruses that are carried by animals less closely related to us. So there's a continuing danger of further spillovers. We know that the HIV virus has spilled over from non-human primates 12 times, 12 different times that we know about. And only one of those is the instance that caused the AIDS pandemic. The other 11 have led to, in one case, HIV-2 is a minor disease in West Africa. It's not nearly as virulent and not nearly as transmissible as HIV-1, the pandemic strain. It's happened 12 times that we know about that a virus has spilled over either from a chimpanzee, a monkey, or a gorilla into humans. Of those 12 times, only one turned into a global pandemic. But it tells us that this is not a highly improbable event, and there could be more.
And the same is true of other diseases. Ebola may reappear somewhere at some point.
Ebola will presumably reappear, yeah. And we still don't know. We know that chimpanzees are the reservoir host for HIV, the precursor virus. We still do not know what the reservoir host is, the non-human animal is, that carries Ebola virus. I did a piece in National Geographic that came out in July on that subject, the search for the reservoir host of Ebola, mystery still unsolved.
I want to turn to your questions in just a moment, but I want to ask one other question of you, David Quammen, following up on what we've been discussing. After spending, well, how long did the big version of this book take, by the way?
About 6 years.
A mere 6 years. Okay, that's cool. Once you pulled your head out of that, did you come to see the world a little differently or a little more profoundly? Just thinking about the AIDS story as not a 30 or 40-year-old story, but a century-old story changes the way that I think about things.
It changed the way I think about things too. It made me, you might think it would have made me more paranoid about viruses and other infectious agents. It made me less so, even with Ebola, because the more I learned about it, the more I realized that these things are not mystical, magical, preternatural monsters or threats. These are viruses. These are just viruses. They have an ecology, they have an evolutionary biology. They can't perform miracles. They want to survive, they want to transmit, they want to replicate. But the more I saw it in the ecological and evolutionary perspective, the more serious, the more sobering, and the less mysteriously terrifying it was for me.
The book is The Chimp and the River. The author is David Quammen. Why don't you give him a round of applause?
Thank you. Thank you. Thank you. Thank you.
I do see a couple of microphones, one over here, one over here. I suppose our process will be if you have a question for David Quammen, why don't you line up at the microphone. I'll call on one of you or the other. And can I ask you to just say your name before you ask, and let's just ask fairly direct questions of this gentleman for a few minutes here. Please go ahead.
Hi, I'm Rob. I'm not sure this is fairly direct. 30 years ago, you wrote in Natural Acts that you were a dilettante and a haunter of libraries and not a scientist. Would you change your characterization of yourself after your long and passionate career? Thank you.
It's Rob. Thank you, Rob. Yeah, I used to write a column called Natural Acts in Outside Magazine, starting in about 1981. And it was about science. And I knew very little science when I started writing it. I was I was not trained as a scientist. I started my writing career as a fiction writer, a novelist. So it's been on-the-job training for me essentially since 1980. I'm a science explainer practicing without a license, a science journalist practicing without a license. I have no training in science, but then again, I have no training in journalism.
This is maybe a good point to point out. This is one of the great things about our Constitution, is that you need no qualifications whatsoever to write a book. So that's really...
It's true.
It's in the Constitution. It is protected right there. And I also want to say, I think that it's something that I really appreciate about how this is written and the writings of a lot of writers in your situation. Because if you're outside of a subject, outside the expertise of a subject, you ask basic fundamental questions. How does this work? What does this mean? Mm-hmm. And having been in the position of knowing nothing and asking questions of people a lot, I often find that I confound the experts simply by asking those basic questions because they've stopped asking. So I appreciate the position that you're in of saying, I'm curious about this, explain it to me.
In some ways, being an outsider helps.
There you go. Yes, ma'am.
Hi, my name is Alana. My question is actually about your book on Ebola. So since you published the excerpt last September, are you planning to publish an updated version taking into account the international response now that we're on the downward side of the crisis, as well as the ring vaccination?
Well, the quick answer is no. I continue to be very interested in the subject of Ebola. I said I did this piece for National Geographic. I've got another book project and another big National Geographic project I'm working on now. I continue to follow the Ebola situation. It fascinates me and it breaks my heart. But until more is done, I'm not a public health writer. I'm not Sherry Fink, one of my wonderful colleagues who has written a lot about Ebola from the standpoint of public health. And there are others who were there, covered the outbreak in West Africa. I'm not a public health writer. I'm not that kind of a journalist. I write about ecology and evolutionary biology. When there is new evidence, when there are new discoveries about the ecology and evolutionary biology of Ebola, I definitely will jump back in.
I'm like really impressed that this audience is like so up on this man's like backdrop. When have you ever heard an author question about something he wrote 30 years ago, right? Go right ahead, please.
Thank you. My name is Joel, and I had a question on the reservoirs and the non-human primates. When AIDS finally broke, as you mentioned, in LA, New York, there was tremendous political controversy over that, tremendous stigmatism over who would have it, who was dying from it, blockaded research for years, and so on and so forth. Do you expect that similar thing to arise if there's another primate-related disease?
I hope not. I hope we've learned a lot of lessons from that. The whole matter of stigmatizing AIDS victims and researchers and all of that dark medieval stuff that went on in the early 80s. I hope we're past that. I'm not confident that we necessarily are, but I think people are realizing that it's very important to understand not just how these diseases work in humans, but where they come from and how they get into humans, how they spill over, the where and the when and the how, as well as what happens to human health. So if there are more of these, I would hope that we would be able to to make much faster progress than was the case with the AIDS pandemic.
When you think about the public response to AIDS in the 80s and compare it to the public response to Ebola in the last couple of years, did you see signs that people had learned very much?
Oy vey. The response to Ebola last year was really, really distressing. I was involved in it to some extent. I was getting pulled in as a talking head amid a lot of other talking heads, and I was being asked questions that I thought, you should not be asking me that question. I'll talk to you about the ecology and evolutionary biology of Ebola virus, but you shouldn't, Anderson Cooper, you should not be asking me what I think should be the immigration policies, the airport screening policies about people coming back into the U.S. from West Africa. But but I was in that position a number of times. There was a lot of xenophobia. There was a lot of confusion. There were a relatively small number of people trying hard to keep it real, to dissipate that confusion, to give people the facts, and there was a lot of screaming and hollering. So thanks for reminding me, Steve. About the great progress we've made.
Well, I guess, is there something in that, though? I mean, the population is constantly changing. The facts are always a little different.
They're
We're
always a little
learning.
different. Right, yeah. And, I mean, we had thought it had been an article of faith that Ebola did not ride airplanes well. Ebola had never left the continent of Africa in a living person before last year, except one time when a Swiss woman who performed an autopsy on a chimpanzee had picked up Ebola, and she was medevaced. They knew she had some horrible disease, and she was medevaced to Switzerland, and she had Ebola in her body. That was the only time before last year that Ebola ever left the continent of Africa in a living human. And people said, well, it doesn't ride airplanes very well. It's too extreme. Well, we turned out that it doesn't ride airplanes real well, but it can ride airplanes.
Yeah. You learn as you go. Learn as you go. Go right over here.
My name is Gary, and I'd like to talk to you after you're off stage about something that's different. But here's the question for the room. Do you think that we can help the world if we can convince people who are eating primates to thoroughly cook the meat before they eat it? Would that possibly help reduce transmissibility of any kind of viri?
Not necessarily, because for instance, with HIV, it passes blood to blood, and that can happen during butchering of an animal before you cook it. It is not a gastrointestinal virus. If somebody swallows a piece of undercooked chimpanzee that's carrying the precursor virus, and they don't have any open sores in their mouth or in their throat, the chances are that they will not become infected. But if somebody butchers an animal that is positive for this virus or another virus, another blood-borne carried virus, and gets a cut or has a cut, then the virus can be transmitted. I mean, the real solution is to provide people with alternatives so that they can eat, so they can feed their children, so that they don't have to engage in risky behavior, which is also bad in terms of conservation of endangered primate populations, bad behavior that involves killing, slaughtering, butchering, and eating non-human primates. We need to give them we need to help them develop alternatives.
Let me come over here. Go right ahead.
Hi, my name is Alex. I have a question about the common ancestry that you were talking about. You mentioned DRC60 and ZR59, and when analyzed, they showed a common ancestor from 50 years before that, which is roughly 1908. I'm wondering how we know that that's the common ancestor, or that it's closely related to when the virus jumps to humans, and how we don't know that it's just a common ancestor that was part of the timeline.
Yeah.
Like, how do we know that it didn't go back 50 years before
We don't.
that?
You're absolutely right. That's a minimum estimate. We know that those two had a common ancestor that was the human form of the virus back about 50 years ago. But it's possible that the spillover could have occurred earlier than that. We don't know how much earlier. We don't have any evidence on that.
Let's take two more quick questions. Right over here.
How you doing? My name is Russell. Big fan. I devour your books in a matter of days. So my question is more on continuity and research funding. So with this 2014 variant in Mayinga, you see that there's about a 3% mutation rate inherent in RNA viruses. However, the fact that that moved from West Africa for the first time, research funding, billions of dollars, and also bam, Ebola is not a hot topic anymore. The funding no one can find anymore. How do we as constituents ensure that the funding for research does not dry up? Because it's going to happen again. You see this from 1976 when it came out in Mbuku to all the way up to West Africa to Sierra, and then you have this really genetic mutation, the fact that it's more stable in certain clinical matrices, and the research and literature shows that. but it's not a hot topic anymore. So what
Yeah.
do we do, and what do the policymakers do? How do you ensure that funding does not dry up because it's not a hot topic, it's gone?
It's a little
Yeah.
hard to hear, so I'm just going to try to summarize. You're essentially asking how does the public get research dollars to diseases at the right time rather than the politically convenient time or when there's a lot of attention
Exactly.
paid.
How do we translate that scientific knowledge into a matter that's, not for the scientific literate, so to speak? The fact that this was really a big deal to have something so serious like 20,000 affected over.
Yeah.
I mean, that's a big deal. It's
Well,
not something that just can go away like that.
Yeah, let me say two things about that. One is that on the problem itself, you're absolutely right that continuity of research funding is very important and has been not very good, particularly with Ebola. Less so with HIV because it was perceived as such a global problem that involved us in the U.S. Two, it was very personal to us, and therefore there was a lot of money put into AIDS research. That's not to say necessarily enough. With Ebola, no. Ebola was perceived as this distant, boutique African disease, and the researchers themselves told me when I did the research for this piece in National Geographic about the reservoir host, they said, one of the reasons we haven't found the reservoir host is that there's an Ebola outbreak and everybody gets excited and concerned about it, and we respond and we try and stop the Ebola outbreak, and in the past we have. 300 people here, 200 people there, and it stops. And then the funding goes away, and the interest goes away, and the virus disappears back into its reservoir host, and we're left with no research funds to continue the difficult work on trying to detect where it comes from, the reservoir host, where it lives when it's not infecting humans. What can we do about that? Well, we can, we're voters, and we're taxpayers, and we can write letters, and we can make phone calls. And so we have to tell our representatives that we want the CDC to have a good research budget, and we want the NIH to have a good research budget. We care about these things. These things are important, including the diseases that we think of as primarily African diseases, because last year showed us that something that is perceived to be an African disease can scare the bejesus out of people all around the world.
That's a profound thought to end on. I'm going to stop right there. Let me just ask you before you applaud, are you signing books here today?
I am signing books, and somebody but not I knows where that
Just
happens.
the time. What time? Do you know?
1 o'clock.
1 o'clock, at 1 o'clock.
Right after
Okay.
this.
David Quammen, The Chimp in the River.
Thank you very much. Thank you very much. Thank you.
Well done.
This has been a presentation of the Library of Congress. Visit us at loc.gov.